All right. Today we are going to look at frequency tables and histograms. Now, first of all, histograms. If you have this large set of data here, like we do, this is 30 students. This is their latest test. Here are all the scores. There's 30 of numbers here. If you were to use a regular bar graph, there's not too many numbers that repeat themselves. So if you were to show the frequency of these scores and graph that using a regular bar graph, you would have like 27 to 30 bars, and the bars would be very low. They would only go up to, in your graph here, 1 or maybe 2 if two numbers are repeated, and it just wouldn't look right. It'd take a lot of time. So that's why we use histograms whenever you have a large set of data and you want to group the data together so it's more manageable. We use histograms, and that's what we're going to do today, is use a histogram to graph this data. But before we get to the actual histogram, we need to organize a frequency table, and a frequency table is used to create groups of these scores, because again, if you use each number as its own bar or score, you're going to have a lot of bars. We want intervals or groupings of them to make our graph more manageable. So you look at our scores here, and our lowest score is right here. It's a 50. And if you take a look at the range, the higher end, we have a 90, we got a 95 here, a 97. So 97 is our largest. So when you organize your groupings down here in my frequency table, I want to make sure that my groupings are the exact same size. If it's not, and you'll see later when we organize the graph, your graph will become biased because certain bars will represent larger groupings or smaller groupings and so on. So because my smallest number is 50, my first grouping will start at 50 and will go to 59. Now I say 59 because my next grouping will be 60. If I say 50 to 60, and then down here 60 to 70, well, if someone gets a score of 60, which is not, I don't see it right now, well, where does the tally go? Does it go into this grouping or this grouping? So you cannot have repeated numbers. So that's why I'm saying 50 to 59, and then 60 to 69. And if you were to count the size of these intervals, they all equal 10. They're all the same. You have to make sure they're all the same to avoid bias. 70 to 79, 80 to 89, and 90 to 99. There's no one got perfect 100%, so we don't have to worry about that right now. So now I'll do my tallies. So from 50 to 59, well, let's see who got in the 50s here. We have 1. We got 2. We got 3. And that's it. So our frequency from 50 to 59 is 3. 60 to 69, I'll actually do this a different color to avoid any kind of NES confusion. Let's just do this color here. 60 to 69, so we got 1. We got 2. 3, 66. We got 4. We got 5. I'll cross them out to represent my 5. And that's it. So now I got 5. I'm going to do the rest of them now to save some time. So I'll be back in a second. All right, so I did the 70s and the 80s here. I'll just finish off with the 90s. We've got 1, 2, 3, and 4. 2, 3, 4. All right, and there's my final tally. So just to double check again, we got 30 scores here. So if we were to add these up to make sure, we have 30, 7 and 3 is 10, 11 is 21, 5, 26, plus an additional 4 equals 30. So we have all of our numbers here. Now, the more you group them together, so the larger the groupings are, the more general your data becomes. So let's say you want to figure out, again, 50 to 59 is a D, 60 to 69 is a C, so that's a B, 80 to 89 is an A plus, and so on. Well, what if you want to know more specific data, let's say C pluses, or, well, you can group them up, 50 to 54, then 55 to 59, then 60 to 64, then 65 to 69, and do that. You have more groupings, and your data becomes a little bit more specific. It's a good thing to remember in histograms, you want your groupings somewhere between the range of 5 to 10 groupings. So if you want more specific data, you want more groupings, the less groupings you have, the more general data becomes. So let's now put this now into an actual histogram. I'm going to have to remove this little cam thing. All right, I'm not sure if that worked or not. Well, let's put together this histogram. So select objects, select my graph, and let's start putting in some data. So my first score here is I have a 3. My second bar will be 5. Third bar is 11. Fourth bar is 7. And my fifth bar is a 4. Okay. Hopefully you guys can see that. All right. Now, differences between a bar graph and a histogram. A histogram, first of all, the bars are always connected together. The reason being is if you look back at what this data means, it's continuous data. It's not different groupings like in a bar graph. You have continuous data. They all mean the same thing. They are continually going from 50 to 99. They're not separate groupings. So that's why we join the bars together. And it's not necessary for you to write the full intervals to represent each bar either. Because they're continuous data, you may just do this. So I'm going to go back to my yellow color here. And I'm going to write my first number, my first interval, which is 50, because that represents the start of this bar here. The start of the second bar, which is 60, I'm going to write down here. And because I'm doing it this way, 70, which represents the start of this bar, 80 represents the start of the bar here. Oh, I can move it. Whee! Look at that. I didn't realize I could do that till now. So now, can you see me? I don't know. I'm learning something new. Look at that. I can move this guy around. Yee! So that's 90. And we'll mark this off as 100. No one got 100. And that's the start of the 90 bar there. So again, it's continuous data, 50 to 60. You don't have to write the intervals. And that is your histogram. Again, there's not too many differences between a histogram and a double or a bar graph. The main thing is why you use them. Why you use a histogram? Because you have an enormously large set of data, 30, and you don't want 30 bars to have only a size of a 1 frequency or 2. Because your graph won't be meaningful. So in a histogram, a large set of data, you want to group them together, make sure they're all equal groupings, And then you put the bars together to represent continual data. And you can do it this way here again because you're not separating groups. They're all meaning the same thing. They all mean the same thing, sorry. And that's that. Histograms, frequency tables, and now you guys can have fun as well calculating mode, median, and mean of all your data. That's it. Whee!